What we call as flow chart over here is also something that we call process flow, because it indicates what process followed by what process or decision, and then followed by what process until the end. What we need for designing RTL system is data flow instead. Let us start the conversion of this process flow or flow chart into data flow. First of all, it is obvious that we are going to need to keep two values, N1 and N2. So obviously we need two registers. These two registers, let's say we name it N1 reg to keep N1 or number 1, and N2 reg to keep number 2. This is how we draw the register. The notch here is to indicate that it is a register. This thing is supposed to get clock input, but we're not going to draw it because it will clutter our diagram. So this is the initial state. Then looking at the process flow, there are two stages of decision here, actually comparing the status of N1 and N2. Either they are equal or N1 greater than N2, which in this case is actually comparing all status between N1 and N2, all three of them, either they are the same or not the same. So this is a very rare case where one comparator will need to issue out all three status lines. And this is also why this algorithm is very good for exercise purposes. So we are going to convert these two stages of comparison into one comparator. Like that. This is comparator. It will be comparing N2 and N1. All three one bit status will be used. If they are equal, the equal line will be raised, and if they are not the same, either N1 is greater than N2 or N2 greater than N1, either one of these two lines, less than or greater than, will be raised up. And this status line will be going to control unit at this side. Then after that, the process say we are going to subtract the smaller from the larger, this one and this one. So we need a subtractor, and then we need to first keep in a temporary register so that later we can put back into the original register, this one, N1 reg or N2 reg. So these two processes are subtraction. We need subtractors like that. So if let's say N1 is larger than N2, we are going to subtract N2 from N1. Otherwise, we are going to subtract N1 from N2. You can trace the line that this one is from N1, and these two lines in the middle is from N2. And we calculate both actually in all state of the calculation, the subtraction of either n1 subtract by n2 or n2 subtract by n1, both will be calculated and kept in these two temporary registers. Sub1 is for this subtraction, n1 subtract with n1 subtract with n2, and n2 subtract n1 is in this register. Then remember, the process says that subtraction will have to go back to the larger value. So we need a feedback like that. But you can see here, this is violating the rule for register. Register is a composition of a few flip-flops, and any flip-flop, either SR, JK, D or T flip-flop, they only get one line of input. We cannot give more than one line of input like this. So basically we need a multiplexer over here, but we will fix this in the next slide. What we need to do now is that the drawing here is too much already. It clutters everywhere in the slide. Let us remove the original process flow. The part that we haven't considered is this part. That is the end where we get n1 equal to n2, and that value is the value of GCD. So we can remember this part. So let us clean up our drawing, remove all the shading also. So next we are going to fix this violation and this one also. And later we will put the state table in the control unit.